Hello and welcome to the next lesson, which is on transformations, combined transformations. So no new transformations here, it's just what happens when you're asked to do more than one transformation at once or something like that. So let's read through what we're being asked to look at. So this topic involves questions where you're asked to do more than one of the following transformations we've studied so far. So let's flick back to what kind of transformations have we studied so far. So we have done translations, was the first one we did. What else have we done? We have done rotations. And the next one is, oops, I spelled that wrong. Let's fix that up. Didn't know it was right, don't worry about it. Rotations. We have also done reflections. The next one, what do you think that would be? That would be enlargements. And reductions. And the last one we did was stretches. Remember, stretches involve an invariant line and a scale factor. Enlargements and reductions involve a scale factor and a center of enlargement. Reflections involve a mirror line. Rotations involve angle and a direction and a center of rotation. And translations involve a translation vector. You've got your X movement and your Y movement, like that. Just going back to what we've covered so far. So how can we apply this? Let's see. So we can use capital letters to describe transformations. So of transformations, which one would fit in here? So let's say so capital letters to, for example, we could say, for example, let R, just as a capital letter, so let's call it R. So let R be something. So what kind of transformation involves, could be something that's anti-clockwise by 180 degrees, about 1, -1. That could be a rotation. That's addressed correctly. Let M be something in the line y equals x. So what kind of transformation happens across a line generally? It's a reflection. We could say, for example, let capital T be the something. And we've got a translation vector there, so it must be a translation. So that translation vector, what does it mean? Remember, it kind of goes in the direction x first and then y. So -3, so means go left by 3. So in the negative horizontal direction, because it goes x and y. And up by 8, because it's in the positive y direction. That's what that translation vector means. Let W be something with an invariant line. So remember invariant lines, y equals 1 and a scale factor of 1/3. So that would have to be a stretch, because stretches involve invariant lines and scale factors. Some people call them stretch factors. Another example, let E be something with the center of the origin and a scale factor of 3. Would be an enlargement. So we can use capital letters to represent enlargements and reductions. Okay, so let's continue right along. So when there is more than one transformation, we can combine the capital letters. However, counterintuitively, the first transformation becomes the second letter, i.e. this one, and the last transformation that occurs is the first letter, M. So MT, according to the ones above, remember M is a reflection in the line y equals x, and T is a translation of -3, 8, according to the ones I've just made up on the spot above. So MT would be, first of all, remember the second letter is what happens first. So first of all, translation of -3 and 8, according to the descriptions I've got above, and then, so in this order, and then the second letter, what's M? A reflection in the line, and then a reflection in the line, y equals x. That's what that would be. So that's what's kind of counterintuitive. Is the second letter is the first transformation that occurs, and the first letter is the second transformation that occurs. So T first and then N. something like ER would be, so R is what occurs first. So what's R? So first of all, so let's see, what is R? A rotation anti-clockwise by 180 degrees about. Center of rotation, 1, -1. So first of all, a rotation anti-clockwise by 180 degrees about. Center of rotation, 1 and -1. Then would be the first letter, B, which according to E above, it's an enlargement with center 0, 0, and K equals 3. So then an enlargement with center 0, 0, and scale sector K equals 3. Alright. So the thing that to note is, in this case you would do R first. In this case we would do T first. And that's what's counterintuitive. So that's worth making a few notes about that. Let's go to the next page. If it will let me. Here we go. It's a nice little example. So what we're asked to do in this one, so for triangle ABC with A's coordinates of A, B and C, so what you're asked to do is, if R is a reflection in the x-axis, so reflection in the x-axis, and M is a reflection in the line y equals -x, what single transformation is equivalent to Rm and Mr? So you might not have coordinate planes drawn on your sheet, so if you haven't, you might want to pause and draw them up now, and I would make them from at least -5 to 5 on the x and y axis. I've got -5, 6 to 6 on the x and y axis, so you might want to pause and do that now. Make sure to use a ruler and evenly space your lines and your scale. And so hopefully you've done that now, and let's continue on with this. So according to M, so we need to, the first one we need to do M first. Is what we have to do with that one. So first of all, let's draw the original triangle. So triangle that, that, and that. Let's draw our lovely little object. I'm going to draw my object in red because that's my little habit. So A is cross 2, up 1. B is 4 and 2. C is 4 and 1. Here's our lovely little object that I've drawn in red. Now my final results I'm going to do in pink. So I'm going to do M first. So I'll do M in purple. So let's see, M in purple. Turn it into purple. So I've got to do M first. What was M? M is a reflection in the line y equals x. So you've actually unfortunately got to also on top of that draw the line y equals x first. Oh no, it's not. Yeah, so that y equals -x. Sorry, what am I saying? Y equals -x. So you have to first of all maybe draw that line y equals -x first of all. So we might want to use a ruler, maybe use a faint thing. So first of all, just pointing out -x would kind of cut through the y-intercept of 0, and -2, 2, 3, 3, 3, -3, 4, -4, and so on. -2, 2, -3, 3, and so on. So, and now I might kind of just use my little line tool, and you can use a ruler to make your nice little line kind of cutting through there. There's there, very roughly drawn, is your line y equals x. Okay, I have problems because of boards. Y equals x. It's not y equals x, it's y equals -x. Y equals -x. I'm going to select yellow first. y equals negative x. Select yellow, let's just stick with green. Cool. So I have to do m first. M is a reflection in the line y equals negative x. So that's what I'm going to do first. I'm going to do this in purple if it will let me do it in purple. Fingers crossed. Let's see what happens when I try to select purple. Will it make purple happen? No, it won't. It's making it black. That's okay, I'll just do it in black. So M, reflection in the line y equals negative x. So let's see, if I reflected this line across negative x, where would this little point A, where would that end up if I reflected it across that yellow line? So try to think, to go from A to the yellow line, I need to go back 2, down 1. So I almost have to do something similar, very similar, but instead I'll need to go kind of down from the yellow line. I need to go down 2, and no, I don't have to do that. Just 1 second. Okay, I see what I was doing wrong. I was looking at the wrong answer of mine. Okay, so this is all fine now. So sort of notice it's kind of go across, back 2, down 1. So same thing, if you kind of go back 2 and down 1, then put a point there. And see, they're kind of both equidistant. They're kind of, if you look diagonally, mirror image, then those two black dots are mirror images of each other. Okay, so now I might want to do the mirror image of this little baby. So this little baby, where's it going to end up? So you can kind of like roughly maybe guess, if you kind of draw a mirror line, across the mirror line, you'll see that it kind of ends up here. Similarly, to get to the mirror line, it's like kind of going across 2, down 3. So instead kind of going, right. Whoops, nope, almost there. Oops, sorry, eraser. Again, I've got problems because my board is stretched vertically when I look at these ones. They're all, smart boards are all stretched out. So actually I was right, my original answers were correct on the sheet. So if I kind of am going down across, so instead I should go across and down to here. So on your page that looks better, on my board this looks really weird because I'm stretched, my board is quite stretched vertically, but on your paper it should look fine. And then this little point here that we're about to do will be 2 units down this way. Up, see they're nice mirror images of each other, those 2 lines, and this little point here, here over here. So when you do your mirror image, it should look nice. On my board it looks weird, but on the video it should look totally okay. It's not stretched vertically, it's just what's happening on the smart board right now. So that is what happens after we've done M. So if you want to keep track of what you've done, you're welcome to label that M. And that was a reflection across the line y equals negative x. What we need to do now is we need to do what the first letter is. The first letter is R. According to what it says above, R is a reflection in the x-axis. So what's the x-axis again? It's this line through here. So we need to reflect across the line. So I'm unfortunately on this board for some reason not able to select different colours at the moment, so I just have to go with that. So reflecting across there, this little point here will be 2 units above the x-axis, just there. This little point here will be 4 units above the x-axis, just here. And this little point here will instead be 4 units above negative 2. So just there. Let's keep it all up. Start with this board, hey. And that's what we have so far. I'll just try to erase that. Who knows what's up with the boards these days? They've gone a bit crazy. Try to just squeeze it better. Right? Doesn't seem to want to draw a straight line these days. I don't know what's going on there. Perhaps it's just the blue. So let's erase this. And erase that. And I'll do it in green instead. Let's see if it fixes for me with a green pen. So 2, yeah. I don't know why, but there's a little squiggle going on there. So please make your triangle look normal. See if I can do it on the laptop instead. Sorry about this, it's probably frustrating to watch. So on the laptop, I can potentially do it with purple. So here's a point here, here's a point here, here's a point here. That's better. And you're hopefully using little rulers to do yours, or a very careful hand because they're very small triangles. And here's our little image. So our object was in red, our image is in purple. So here's our object. And purple is our final image if you want to add further to. That comes in to do that. So they want to know what is the overall transformation that you see there. So going from the red object to the purple image, how could you describe that as just a single transformation? So pretend that this one down here never even happened. How could you describe going from the red one to the purple one in just one single transformation? So you've probably guessed it's a bit of a rotation, and it is a rotation around the origin, because if you do the origin here, this point corresponds with this point, and you can draw a nice right angle between the two of them. So it's a right angle, so it's a 90-degree turn. And is it clockwise or is it anti-clockwise? You're kind of turning this direction, aren't you? So you're going from the red one to the purple. Is that clockwise or anti-clockwise? That's right, it's anti-clockwise. So let's write down what that would be. So this one is Rm. Rm would be, as a single rotation, a rotation, let's say the degrees and the direction, anti-clockwise, and we've got to say what the centre of rotation is, about the origin, working like 0, 0 as a coordinate. So that's our centre of rotation right there. Brilliant, so that one's been done now, so we can probably move on from there. Brilliant, now let's do II. So MR, what we need to do is, for MR, we need to do R first, because the second letter is the one we do first. So first we've got to reflect in the x-axis, and then we've got to do M, which is reflecting the line y equals negative x. So first things first, let's draw our object again. The same object as above, that one. So let's quickly plot that. A is 2 and 1. Hopefully you've paused and drawn your x and y axis, and you've got it popped in your scale if it's not already drawn for you. 4 and 2, A, B and C. So here's our object. Object is drawn, no problems. So we have to do R first. R is the reflection in the x-axis. So remember the x-axis, this thing here, we're going to reflect across that. That's easily done. So I'm going to do that in black. So let's do that first. So reflection in the x-axis. So this point will go down here suddenly. This point will now be equidistant there. This point will be down here. So you've probably found reflections pretty easy so far, I bet. So if you look at it sideways, it's they're mirror images of each other. And now we need to draw our image. But in order to do that, we've kind of got to have our lovely little y equals negative x line drawn again. So y equals negative x, it's got a y-intercept of 0, 1 matches up with negative 1, and so on. So you might want to plot this line and draw it faintly if you want. Definitely whenever you do these, please use something erasable, like erasable pen or pencil, because this is a bit of a nightmare if you have to cross it all out and do it again, and you've got to write over something you've done already. So let's mark in, here's our mirror line for this particular transformation, and I'm going to label it y equals x. It's not weird. Sometimes it allows me to do yellow, and sometimes it doesn't. So y equals x. I really want to do yellow for some reason, so I'm going to undo that. I just want it to be the same colour. So I'm going to use the laptop to write it instead. Y equals, sorry, and it's negative x. I keep saying y equals x. It's negative x. Hopefully you picked up from my tendencies to do that. Okay, next what we've got to do is we have to now do M, because we did R first, we've got to do M. M is a reflection in the line y equals negative x. So I'm going to use purple, because that's what I'm going to do my image with. I'm going to use a laptop. So I'm reflecting the black image. Remember, like, what we're reflecting is the thing you've just done. So we're reflecting the black image that I've done, not the red object, because we've already created the image of that object to begin with. Now let's create the final image by doing the transformation of M on the black diagram. So reflection across, let's see, where would it end up? We're at this little point. If you reflect it across, this little point here will become that little point there. Reflect that across, this little point here will become that little point there. And this little point here will become that little point there. And then just connect them up. Again, this looks really warped on my smartboard because it's stretched vertically, so they don't look like mirror images of each other. That's what was messing me around on the first one. But when it's done on your piece of paper, they do, because your piece of paper isn't warped, and on the video it shouldn't be warped either. The proportion should be correct. There you go. And so drawing the diagram is really just to help us see what single transformation is equivalent to going from the red object to the purple image. So you could, if you wanted to, remind yourself that that is the object. In purple you can write purple diagram is the image. So what we're doing is MR. So what single transformation could you describe going from the red object to the purple final image? What's a single transformation that is like that? So let's see, have a little look. It's not really a reflection or anything. There's I'm not really reflecting across y equals x or anything like that. You might have a think and decide, that looks like a rotation to me. So would you agree that it's kind of a rotation in the clockwise direction this time? So beforehand we were going anti-clockwise by 90 degrees. This time we seem to be going clockwise by 90 degrees. And what's our center of rotation? That's right, the center of rotation is the origin again. From the origin, these 2 points correspond with each other. From the origin, you can draw a nice little 90-degree angle there. So that means it rotates around the origin. So it's a MR is a rotation, would be a rotation. We've got to say how many degrees. 90 degrees. We've got to say the direction. Clockwise this time, not anti-clockwise, so clockwise this time. About the origin. If you're not sure what I'm meaning by origin, just reminding you that it's that point 0, 0. This little point here is correct. Sometimes people describe it as O, capital letter O. Could also say that as well. But I tend to say origin, or the coordinate. That's a bit more clear then. Great, so that one's done. We can finally move on from there. So similar, same original triangle up here. And again, you're going to need to draw some axes for these ones, sorry. So if you haven't got these axes already drawn for you, you'll need to pause now and draw them up. Again, just going from -5 to 5 on the x and y axis would be fine for both of them. Sorry, just had to pause, someone walked in the room. So let's see, so it's the same, so hopefully you've drawn up your axes, and now you can continue on with what we're doing. So if T1 is a clockwise rotation about the origin through 180 degrees, and T2 is a reflection in the y-axis, describe a single transformation equivalent to T2, T1, and then the opposite, reverse of that. So we need to do T1 first. I like to do this to remind myself because it's hard to remember. You do the second thing first, the second that happens first. It's the same initial triangle as what is in the very top of the page. So let's draw our object again. A is at 2, 1, B is at 4, 2, and C is at 4, 1. So I've got a lovely little object which I like to draw in red. Okay, I'll just draw it like this. There we go. Loveliness. There you go, object done. Now what I have to do is T1. What's T1 this time? And I'm going to do T1 in black. T1, clockwise rotation about the center of origin. The center of rotation is the origin, sorry, 0, 0, 180 degrees. Oh my, so what would that look like? So what you might want to do is say from this point here, let's see, if you kind of like, feel free not to draw these in. So imagine there was kind of a straight line kind of cutting from there to there, and you did a 180 degree kind of thing. You would end up just there. So I'm going to plot that point, so I'm going to undo that, because that looks messy. I'm just going to plot my point right here. Sorry to pause again, someone else came in the room. Okay, so we've plotted this little point right here. Now let's see what would happen if we rotated this one 180 degrees. So you could kind of like think, okay, if I cut from here through to the origin, again, this, don't necessarily copy this, because that was kind of bad. So if I rotated this 180 degrees, I'm probably doing a better job than me, I hope. Where would it end up? And you probably guessed correctly. I'm going to undo that because it looks messy. Where would it have ended up? It would have ended up just here. Okay, so hopefully when you draw a line, you can draw sort of a line through here, and they should be equidistant from the center of rotation, which they are, which is brilliant. Oh, hang on. Again, I think my board is warped, so sorry about that. Yes, my board being warped. Let's maybe do something that's different to my answers. So my answers, I'll have to rely on those more because they're kind of drawn on a non-warped kind of piece of paper. So yeah, when you do that, basically, when you cut through here and continue through, you actually end up over here. So if you do a 180 degree rotation, sorry, this one actually ends up over here. But on my board, it looks like it ends up down below. Okay, so that's correct now. And so you can draw a nice straight line through all of that, and there, this little point is equidistant from the center of rotation as this corresponding point. Now same with this. Whoops. Yeah. What's going on there? Just one sec, I'll pause and... Okay, I think it's all good now. Right, so now it's this little point. So if you kind of do a straight line, sort of, yeah, try to do whatever it's meant to end up, and then it's going to end up somewhere different. So if you do a straight line, equidistant, it kind of ends up over there. If you kind of rotate it 180 degrees, it ends up about there. So let me undo that. Here we go. And so that means our little point was right here. The board's been a bit funky, so I'm just going to hand draw it on the laptop instead. And you're hopefully using a little ruler to do yours. Please don't forget a ruler on the day of your test and exams, of course. That's helpful. Okay, let's fix that up. Very difficult to draw on a laptop. That will have to do. So that is what we've done up to T1. Now we've got to do the final image, which is what happens to T1 when it goes through T2. T2 is a reflection in the y-axis. Y-axis, super easy. I've forgotten already. Y-axis is just this line through here. You don't really need to draw it, to be honest. So I'm going to undo it. So y-axis, out of the way. So if I reflect the black image through the y-axis, I will get this purple image. Let's see, and you can probably have a go first, do it in something erasable. So if I reflect it across the y-axis, remember I'm reflecting it across the vertical axis this time, I will end up over here. Here's our lovely little image, our final image in purple. You might want to write that this is your final image. Object pen in purple, I'll write the final image is purple. What you're asked to do is describe a single transformation that would map the red object onto the purple image. So you can't say you did this and then you did this. It has to be a single transformation. So that's pretty easy if you just look at that. kind of transformation do you think that is? Have a little guess. That's right, it's a reflection. And what would be the mirror line? The mirror line would be the x-axis. So we can write T2, T1 would be, or is, a reflection in the x-axis. So going from the object to the purple image. To the purple image. Yeah, I want to draw the purple image. That's the image. Or the final image. Lovely. So what's the next thing we asked to do in II? T1 and T2. So for this one, we have to do T2 first. Do T2 first. So again, we've got to do the original object. The original object is at T1, this one, and this one. It seems to allow me to draw the original object all the time. Okay, cool. Must be something to do with the red pen. So what's T2? T2 is a reflection in the y-axis. They're always easy. I love reflections in the y-axis. They're super easy. Reflection in the y-axis. So this little point would correspond with that little point because the y-axis is the vertical one. This little point would become that little point because the mirror line is this y-axis. And this little point would become that little point. So let's connect those up with a ruler. Wicked. So we've done T2, now we've just got to do T1. Rotation's always a bit trickier. So T1 is a rotation, clockwise rotation, about the origin. So here's our center of rotation here. Do that in blue. Center of rotation is blue. And we've got to do this clockwise rotation. And it's 180 degrees clockwise, so we're going that kind of stuff. So what would this little baby be? This little baby, if you rotated it clockwise, so sort of cutting through here, equidistant kind of this way, would be over here. So that makes sense. We've rotated it clockwise 180 degrees. Down. Point corresponds to that point. This point, if you kind of keep cutting through, where would that end up? That would end up just here. I have to check my diagram because my board is warped. And yeah, so hopefully that's what my answers say on the page that's not warped. This little point, if you kind of cut through here and went equidistant this way, you would end up here. So it makes sense to across that, like the line that we just kind of imaginary line I just drew here. If you rotated this, oh dear. If you rotated this little point 180 degrees that way, you'd end up there. That matches my answers. I should always just be checking my answers instead of relying on what I see on this board. There's our final image, wicked. So let's label this one the object. The red one is the object. The purple one is the final image. Final image. It's good to, like, I know this is obvious, but it's good to write that because you might look back on this in a few weeks and just go, I have no idea what's going on that piece of paper. So then you just realize maybe you went from the red to the black one to the purple one. And write little notes to yourself about that. So they are asking us, what's a single transformation that describes going from the red to the purple? And strangely enough, look, it's the same as this one. What was that transformation? It was a reflection in the x-axis. Same thing, just turned out by complete coincidence. This one also ended up being a reflection in the x-axis. So let's write that out. This time that's T1, T2. T1, T2 would be a reflection in the x-axis. So actually doing the transformations on a coordinate plane is the best way to be able to see what the final, what it helped to describe going from the object to the final image in a single transformation would be. That's the best thing to do, is to actually draw it all out, if possible. Let's keep doing some more little examples so we know we've got the hang of this. So as to draw a triangle OAB, where O is the point 0, 0, the origin, A is 0, 3, and B is 1, negative 3. So that's what we're asked to do first. I'm just going to scroll down so I can do this a little bit easier, but you can be doing this while I'm nattering on. So I love to draw my object in red. So here's one point here, 0, 0. Next point is 0, negative 3, right here. And the next point is 1, negative 3. So hopefully you drew a triangle. Candace looks like this. Nice. And then connect it all up with the ruler. And that freehand. There's our awesome object. So that's question A. What's question B asking us to do? Well, first of all, actually we've got to fill in this info. T, remember we use capital letters sometimes to describe transformations. T is a transformation, positive 90-degree rotation about O, which is the origin. Remember that a positive rotation, think back to rotations, a positive rotation, is it in the clockwise or the anti-clockwise direction? Positive rotation was in the anti-clockwise direction, and that was in your notes for rotations. Anti-clockwise direction. So T is that transformation, it's a 90-degree rotation about O, so anti-clockwise. Another transformation, R, is a transformation, reflect in the line y equals x. So remember, y equals x is just the line that cuts through, like, 6 and negative 6, 5, negative 5. It's got a y-intercept of 0 and continues on that way. So what are we asked to do first of all before we draw all of that? So draw triangle O and the image of A and the image of B. So it's going to be the same point. You're still going to have the same point here. Under the transformation T, label the image T. So T is the rotation about O. So because it's rotating about the center of origin, O, and we have a point on that center of origin. So here's our center of origin, 0, 0. So if you were to draw that point from the object onto its image, because it's on the center of rotation, it's going to actually be on that point itself again. Yeah. And then the next one, if you rotate, see this little point here? If you rotate it at 90 degrees, anti-clockwise, sorry, mine's warped again, I went the wrong way. 90 degrees anti-clockwise, you're going to end up just here. That's where that point's going to be. So you have a line across there. This little point, if you rotate it 90 degrees anti-clockwise, it's going to end up just there. Because from here to here, you make a 90-degree angle. Then let's connect those babies up. And you're asked to label this. What were you asked to label this triangle? Have a look at what the question's asking. That's why I struggle to draw this on my laptop. We were asked to label it T. So let's put a little T in there. Label it T. You only really need to label it if it asks you to. Sometimes it does ask you to do that, by the way. So keep an eye out for that in exam and topic assignment and test questions. Okay, label the image T. We've done B. Okay, so now C. Draw. Notice it's the triangle O, so same point O, 0, 0, A dash dash, B dash dash, which happens to be the image of the black diagram you just drew then, under the transformation R. Label the image RT. Just because the question's asked us to do that, we're just going to label it RT. So under the transformation R. R is transformation, reflect in the line y equals x. You might just be able to see what to do, but I personally love to draw the line y equals x. Just draw it faintly. It's got a y-intercept of 0. Matches up with 1 and 1, 2 and 2, 3 and 3, 4 and 4. Same thing going backwards. -1, -1, -2, -2. Diagonal line, it's got a positive gradient, and I would use a ruler to connect those points up. Fun. This way. Should do stuff with the laptop now instead because the board's a bit unreliable. And this, I like to label my little lines just to remind myself what's going on. This yellow line was just y equals x. So it's going to help me to do my transformation. So the transformation we've been asked to do, I'm going to use in purple because this is going to be our final image. Transformation, we've just been asked to do R. So from the black one, we've got to now make R. Just check, sometimes they want you to use a red one, but they asked us to do O, A dash, B dash, and they want us to transform this one. That's what the question said, see, O, A dash, B dash, and then make it into this. So R is reflection across this line, Y equals X. Easy to do. So notice that this is on this point here on the black point on the triangle is actually on the mirror line. So it just means it's going to be there again. This little point, if you reflect it across that yellow line, you'll get that. This little point, if you reflect it across the mirror line, you'll end up here. So this is our image, our final image in purple. If I could write with this purple pen, I would write final image. You wouldn't have to do this in your topic assignments or tests, like write object and final image. I'm just doing it for the sake of notes. It's my final image, just so I can look back and see what's going on. It's amazing what we forget. Rightio, and what were we... So I think we finished that little question, didn't we? Oh, I forgot to label it. Naughty me. So I'm going to label it RT because that's what they asked us to do. A bit difficult to do in purple, so I'm going to do it in pink. Just because it's a bit too small. RT. Good luck doing that on yours. It's very small, isn't it? RT. So make sure you've completed everything they've asked you to do. State the coordinates of A dash dash and B dash dash. So which one is A dash dash? Let's see. Which one was A? A was this little point here, and then it became A dash there, and then it became A dash dash up here. So it's 0, 3. So A dash dash is 0, 3. 0, 3. And what's B dash dash? Let's have a look above. B dash dash. It was this one, then it became here, and then it reflected and became there. So it's 1, 3. So B dash dash is 1, 3. Lovely. Then you're asked to describe a single transformation. Very popular question in topic assignments, exams, and all that kind of thing. Describe a single transformation that moves triangle OAB, which is the object, the original red one. So it's not the black one, it's the original red one, because there's no dashes on it. Onto the final one, which is in purple. Similar to what we've been asked to do on the other ones. So what would be a single transformation? That would map the red one onto the purple one. Have a little think about it first. You're guessing that it's a reflection. Would be right. Reflection in what line? It's not in the yellow line. It's a reflection across the x-axis. That's what it would be. So we could say RT. You have to say RT, but I'm just going to. RT is a reflection in the x-axis. Brilliante. So what more can I talk to you with? Let's do more examples. Example, draw the triangle whose vertices A are 2, 2, 5, 2 and C 2, 3. Let's do that in red, of course. So A is 2 and 2, B is 5 and 2, C is 2 and 3. You can also label them A, B and C. I'm just finding it very difficult to do on this board. C is 2 and 3, so there. But on your paper it's quite easy to label. On my answers I actually did label them A, B and C. Just these pens are so thick. So that'd be good to do that if you want A, B and C, because you can do that with yours quite easily. pretty awful picture, that one. So hopefully yours is better. Now, B, what are we asked to do? Let's scroll down and see. Draw the image PQR of ABC. So ABC is in red. Forgotten. ABC is in red. Under a half turn. Half turn is how many degrees? 180 degrees. About the origin. The origin is the center of rotation. 0, 0 in this case. It's going to be the center of rotation just because the question said it. And then state the coordinates of P, Q, and R. So we're not going to call the triangle A dash, B dash, C dash, just because the question asked us to call it P, Q, R. So about the origin, so our lovely little center of rotation. Might help to like just mark it in. That's our center of rotation. Start with A. Start with A. So I'm going to, this is going to be a partial thing, so I'm going to cut it across here. If I did a line through there, went equidistant, where is it going to end up? It's going to end up here. According to my answers too, it's good I'm checking my answers as well, because on my board it looks like it ends up there, but on my paper, oh goodness, why does this do this to me? Okay, so across, then if you rotate it, it doesn't say clockwise or anti-clockwise, but let's just assume it's kind of, it just says a half turn, so let's maybe say anti-clockwise, because that's a positive rotation. We'll just assume it's positive. Kind of similar thing really anyway, isn't it, if you went that way or that way? Doesn't really matter because it's 180 degrees. Now let's do B. B, if you kind of drew a line through here and went equidistant kind of this way, you might end up over here. So same thing, if I rotated, what's that line through here? If I rotated 180 degrees, I would land over there. Wicked. This little point here, C, if I kind of cut through here, continued on, I would end up right there. So because here's a line C through the center of rotation. Now if I rotated that 180 degrees anti-clockwise, I'll end up there. So let's draw a lovely little diagram. I'm going to label it just so you realize which point corresponds with which. Because you're asked to state the coordinates of P, Q, and R. So A corresponds with P, because it's P, Q, R, A, B, C. B corresponds with Q, and C corresponds with R. And don't forget you're asked to state what those little coordinates are. So let's say P, what's its coordinates? Coordinates for P is -2, -2. Q, what's its coordinates? It's -5, -2. I hope it doesn't right spot, just checking. Oh no, it's right, it's good. I'm looking at the wrong answer below. R, its coordinates are -2, -3. All good. That's what I see. Now what's C asking me to do? Draw the image LMN of ABC. So notice it's not asking us to transform PQR, it's asking us to transform the red one, ABC. So I'm going to do that just in purple, different colour, just so I've got a bit of a colour code. So this purple one's not going on from this black one, it's happening from ABC. So draw the image LMN of ABC under the translation. So 0, -6. So remember it goes X then Y. So go across none, because it's 0, and vertically, so down 6. Across none and down 6. That's what that translation vector is trying to tell us. And state the coordinates L, M, and N. So we have to do that from our red object. Already red. Translations are easy. Red object. Let's see. A. We're asked to go across none and down 6. Easy peasy. End up at 4. From B, across none, down 6. I'll end up down here. C, across none, down 6. I'll end up right there. So that's good. See, a translation is the same kind of orientation. It's just moved somewhere in space. It hasn't enlarged, hasn't reduced, or anything like that. It's just in a different spot. And they want us to be L, M, N. So L has to correspond with A, M has to correspond with B, and N has to correspond with C. because of the letter order. Cooperate board. Okay. I think it's one of those cases where it doesn't want to draw again. So I'll just have to pause and probably save and close it for a second, sorry. Okay, so I've saved and closed and opened again. So just still trying to label this little point here N. And we need to state the coordinates. So let's see, what's the coordinates of L? It is 2, -4. L is 2, -4. What is M? And so it's 5, -4. And M is 2, -3. That's what we're asked to do. Then you're asked to describe a single transformation which maps PQR. So PQR is not the original object, it was the first image that we did, to LMN. So the black one to the purple one. Single transformation which maps the black one to the purple one. What does that look like to me? Or to you? It's not a reflection, it's more a rotation. The black one is kind of rotated around. 180 degrees, because it's kind of flipped. It's not kind of turned around 90 degrees. It's flipped over. And let's see if I can point out. This little point here corresponds with that little point there. So therefore, the center of rotation would be, have a think, right here. It's a little center of rotation there. And just to prove a point, see this point here corresponds, if you cut through, corresponds with that point there. Good. And this little point here, cut through the center of rotation, corresponds with this little point here. They're equidistant from the center of rotation. So the center of rotation is this point here, and it is 0, -3. So let's describe that single transformation which maps that. So let's say it is a rotation of 180 degrees. Could be clockwise or anti-clockwise, just make one up if you want. Clockwise, about center of rotation, just to remind you of the terminology, so this one writing center of rotation. About center of rotation, 0, -3. That's what that would be. And now, are we up to our lucky last example? Because it's a pretty long lesson, sorry. Showing you some examples of some tricky ones. I'm having board problems. Draw a triangle OAB with O, A, and B. So different coordinates this time. Let's draw our object in red. So we've got a point at the origin, got a point A at -2 and 0. And try drawing B, where would it be? It would be right here. So please use erasable pen or pencil. I made a boo-boo on this. I did it at 1, 1 by mistake to begin with, but it's 0, 1. You might want to label, let's get into the habit of labeling things. O, it's kind of labeled already, to be honest. A and B. So in red. What are we asked to do in the next question? OAB is reflected in the line y = 1. Remember, y = 1 is just a horizontal line that cuts through y = 1. That line there. And then the image is reflected in the y-axis. The y-axis is this one here. So two different sets of reflections. What's B asking us to do? Draw the two images. So draw the image after this one first, and then draw the image after that one next. And state the coordinates of the final images. So state the coordinates of what happens after you've done this. And the single equivalent transformation. So just what we were asked to do before. I'm going to do this one in black, like my little habit has become. And I'm going to do this one in purple. So y = 1. What on earth is that? Y = 1. It is the, as we said, horizontal line that cuts through y = 1. It's horizontal because it cuts through y = 1. If it was vertical, it would cut through x instead. So I love to write this out, just so when I look back I say, what is this yellow line doing there? I realise I've drawn the line y = 1. So we need to reflect this red thing, so I'm going to do it all in black. So point B is on the mirror line, so it's just going to stay there. So B dash is going to be right there. point O, it's going to move equidistant across from the mirror line. It's going to be right here. Point A, going to move equidistant across the mirror line. It's going to be right there. Let's join them up with a ruler. So if you've got a nice pen, as opposed to what I have, you might want to mark this one as being O dash, this one as being A dash. My pens are playing up, so I'm not going to do that, but you should maybe do that if you feel like it. So now I've got to do the purple one. So we're doing lots of things in one steps. Reflection in the y-axis. So you might remember the y-axis is this one going up and down. The x-axis is that one, so don't do that one. Common mistake is people will use the wrong axis, unfortunately. So really make yourself think which one is the y-axis. So reflect the black image across the y-axis. That's pretty easy. This one is on the y-axis, so it's going to stay here. This one is on the y-axis, so it's going to stay here. And this one is not on the y-axis, so it's going to flip over here. Become little mirror images of each other. It's looking a bit messy, isn't it? That's why colours can be helpful. Just see what's going on. So red is our object, and purple is our final image. So that purple pen right with that instead. Final image. So will we have to state the coordinates of anything? No, just find, draw the final images. I'll state the coordinates of the final image. Yep, so we were. So we want to know what the coordinates are. So you might want to label what they are. Yeah, I'm going to select the purple pen and do it on the laptop. So this one here is A dash dash, because A went from here to here to here. So this one is A dash dash. There you go. Oh dear. Please don't make it look like mine. A dash dash. This one here, it went from O, went from up to here, and then it just stayed there. So that one is O dash dash. It happens to also be O dash from the previous black image. We're talking about the purple one. So we'll call it O dash dash. And this little one B just stayed there, so it is B dash dash. Just so when you look back, you see what you're doing. So please use color coding and use consistent color coding throughout this whole unit. Get yourself some nice colored pens. Erasable ones, preferably. B dash dash. What are those little coordinates equal to? So, I can't write the purple one, let me. So, I'll write in green instead. Set the coordinates of the final images. So, let's see, O dash dash. That's its coordinates. 0, 2. That's right, O dash dash was 0, 2. And A dash dash. Let's see, what was that? That was 2, 2. And B dash dash, the diagram above, is 0, 1. Loveliness. Oh, I don't want to draw the dash dash. It's because it's annoying. B dash dash. Okay, so I'll probably need to just scroll down a bit. It's because it doesn't want to. Something's in the way on my board. I didn't want it to do it in purple. We do it in green. B dash dash. Everything's great. So last thing we have to do is describe the single transformation of going from the red to the purple. So red to purple. Oh, what have we done here? Going from red to purple. We reflected. Well, you did reflect and then you reflected, but that's not a single transformation. That's two transformations. So if you're asked to describe it as a single transformation, you can't say we did this and then we did this. Well, you need to describe it as one single transformation. So it is a rotation, and where would be the center of origin? So that's right, the center of origin would be right here. Center of origin would be right here. Did we rotate by 90 degrees, 180 degrees? Of course, 180 degrees. They decide clockwise, anti-clockwise, whatever, kind of same thing really, isn't it? So let's just say clockwise if you want. So let's say what it would be. It is rotation, 180 degrees clockwise, with center of rotation, or you might just say about. Rotation. Notice my spelling of center is the English Australian way. If you're from the US or Canada, you might want to spell it S-E-N-T-E-R. Center of rotation was not the origin, it was 0, 1. Fantastic, now this lesson is finally over. So thank you very much for your patience. And cool, hope it helped. See ya.